Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to take a look at what are the cost of a solar farm. So let's dive right into it. Now first thing, I'm not even going to bother explaining this land. You have to have it. Do not think about it unless you have it. So land, first it must be a shadow free land, as in let's say you have a very large patch of land but there is a mountain or even a hill that casts a shadow most of the day. It's useless. So please check for shadows. And like in all season, you cannot have a scenario where because sun is higher in the basically sky during summer, you may not have a very long shadow, but in winter your whole solar farm can be covered by in shadow, because a small hill that was small in summer is now very long in winter. So please check for shadow and all year around. So you have to do that. And it must be a flat land. You can have a land that is a bit bumpy, but generally it's a wise investment to flatten that out, because in that sort of scenario where you have basically not flattened land, the solar panel itself will start casting shadow on one another. That is a very huge loss. And on top of that, you have to understand the location. So this is a map of India, a rough one. Now this should give you a context. Let's say you are here in Rajasthan kind of area. You're gonna get a lot of power. To give you a context, you're gonna get upwards of 6.5 kilowatt hour per square meter. That's a lot of energy. Now let's say you went into somewhere else, you can have a scenario where you only get 4.4 kilowatt hour. So understand this sort of map matters, because you may be like on paper your solar farm may be should produce this much, but it's producing much less or it's producing much more because of this sort of scenario. So location matters, and I mean thoroughly check this out before you go into it. You may be in a scenario where let's say you are here, you have a lot of solar energy, but there is like dust storm 24/7. So you have to pay attention to the location aspect. Now I'm gonna give you a very simple, narrowed down, dumb mathematics on how this works. 1 hectare of land, as in 100 meter by 100 meter, should give you upwards of 1 megawatt of power, and that should cost you roughly 5 crore rupees. Now this is a rough estimate. This is something that you start on. Like, do not take this and run with it. The money will change dramatically depending on your supplier, depending on your government cost and all that. All those things play into fact, but this is a rough idea. 1 hectare is 1 megawatt, and then you should expect to spend upwards of 5 crore. Now plus minus 10-20% to 30-40%, that's acceptable, but do not go away 100% away from this. So if like somebody says for 1 megawatt they are charging 10 crore, unless they're giving you magical solar panels, that is a scam. So this should give you a rough idea. Have a land, then you should have how many lands, like what kind of surface area we are talking about. That will explain how much megawatt you're gonna get. So before you put solar farm, before you buy solar panels, you must have to make sure that you have frame, basically where you're gonna mount the solar panel. Now it must be understood very thoroughly that because of the giant flat smooth surface of solar panels, they are a wind hazard. So because if wind goes through a rough surface, it loses a lot of its energy, but if it's going through a smooth surface, it can enact a lot of wind pressure. So when you have giant solar panels, like acres of this must be tested for wind. So whenever you have a scenario where a proper engineer does it, they first study the plane, basically what kind of wind they are supposed to expect, and then they will build the pylon, basically where the frame is there, such a way that it can handle winds. Because wind, you may not think it's a big issue, but it does become a very giant issue because of this giant flat plane. So you must make sure that your engineer is checking for the wind. On top of that, do you want an adjustable solar system or flexible one? Now generally people go for fixed one because it's cheap, it's very quick, very long-term reliable. However, in certain scenario, it does come with a consequence that the power output is very less. So then comes a best case scenario, which is what we call dual axis tracker. Now if you have a very small farm, as in like only say 100 or 200 kilowatt, you may be able to get away with dual axis tracker. Benefit of that is, like, even though your frame cost is much higher now and it has motors on top of that, and it's like it does consume a little bit of energy, you can expect upwards of 30% more power out of your solar farm. So that is significant enough that in some scenarios it makes sense to have a dual axis tracking system. In other scenario, generally people try to get one axis system. So basically sun is going like this, from your morning to night. Now you don't need to track this. but you do need to track what happens during winter and summer. So basically sun's arc is like this in summer, in winter it would be almost horizontal. So in those sort of scenario, people use something like this. Basically this panel will only rotate for summer and winter, so it's not gonna do every day, not from morning to evening, but over time, basically let's say from March to December, it is slowly gonna tilt towards the horizon, so it can absorb more of the winter. And that way the mechanism for this neither has to be very high powered, so it can keep up with the speed. It is very slow, one axis, it will last longer. So generally that is the compromise people do. They can have basically one axis tracking system. It's up to you. If you think you are low on money, go for fixed one. If you think you are high on money and you can afford that, go for dual axis. But be aware, dual axis does not make sense for very large solar farms. For smallish it makes sense. However, hybrid or single axis system, where you're gonna basically adjust a single nut, basically like a single thing, and it's gonna affect your winter and summer performance, it may be a viable solution. And please try to build a continuous array, basically one long strands. If you sometimes people have uneven ground and they try to save money by having one small unit, you are wasting land. You're not gonna get more land. So please try to get continuous array. Continuous array are the best. And there have been some solar farms where they have ludicrously huge ones, and they dug trenches, basically a small section in the ground. That's how people can go around. So you won't even have this access panel. So there are certain clever ways you can do to make sure you maximize 100% of the land use. However, do not do that in some places where it rains a lot. That will become a nightmare. So this is the frame aspect, and on top of that, please do not cheap out on material. If somebody sells you normal cheap steel versus stainless steel, go for stainless steel. If somebody gives you aluminum, go for aluminum, because these things supposed to last for 25 to 30 years or even 50-60 years, because there is nothing inherently stressful about this scenario. So you can have a scenario where you changed a solar panel after solar panel after solar panel, let's say for 50-60 years. So you want your frame to be a sturdy investment. So do not cheap out on the frame. Now we come to the star of the show, basically solar panel. Rule number one, even if let's say you are going for a simple basic solar farm, do not cheap out on the panel. Here it matters, because your quality of your panel will directly affect the ROI. What is this ROI? Basically what we call return on investment. Basically you put, let's say 5 crore, how long before that 5 crore come back to you? So it could take upwards of 5 to 7 years. So those sort of scenario directly comes from basically quality. If you have big panels, let's say these panels are generally 250 watt. Let's say somebody is selling you 300 watt panel, go for 300 watt panel. The reason for that is the bigger the panel, the less the wiring, the less the clamps that you have to put in between. Basically it helps you utilize more surface area properly. So bigger panel is always better, unless there is some panel that are that's only 10% more but costing 50% more. Yeah, then look about it, but generally try to be above 250 watts. 250 watt per panel generally, and you can nowadays easily get upwards of 300 to 350 watts. Try to get as big as possible. That will reduce the amount of wiring you have to do. That will reduce the amount of wasted space, because you can see there all panels are generally mounted from the side, so it does waste a lot of space. So that will also help you improve your land usage. And please read the fine print. This is how you can tell whether the solar panel is a good quality or not. Does it have detail? Because be aware, there are many companies that make solar panel, but there are very few companies that makes the solar cell. There are very few companies that do that. So you can have a scenario where, let's say, Sun Power is making your solar panel, but Hissy Industries are the one that is making the actual solar cell. So please look into the fine print. Who is making the cell? Not the panel, because panel can be locally manufactured, but who is making the cell? And please read the fine print. There are hundreds of data points in this. The most important one is the temperature gradient, because on the panel itself they will simply tell you, let's say this is a 305 watt panel. Okay, awesome, but that is at 25 degrees Celsius, but you do not know how your panel is going to react at 60 degrees Celsius. So for that you have to go into deep and find in the company, call them up, hey, can you share the data sheet or where there is a graph, things like that. So using that you can actually figure out how much energy you're gonna get. And this is very crucial, because this temperature efficiency this is where people lose their mind. It's like, hey, I put 1 megawatt farm and I'm only getting 800 kilowatt because of that, because it was rated for 1 megawatt at 25 degrees Celsius. You are in sunlight, you're not gonna be at 25 degrees Celsius, you're gonna be at 30 to 50 minimum, even in winter. So understand this. And warranty will give you a very clear idea. If a company gives you warranty of, let's say, 10 years, yeah, don't trust it. If a company gives you 20 years, good, then please read the detail, because let's say you buy monocrystalline panels, they generally have a much better warranty terms, because they can simply give you the power loss will be only 85%. Now if you buy multi-crystalline, basically the blue color solar panel, they will tell you no, the power loss would be upwards of 80%. The monocrystal is generally better, but it costs more. So if you can afford it, go with mono. If you can't, don't worry about it. So do not cheap out on solar panel. This is the longest running, basically longest lived part in your solar plant, other than the metal frame itself. So please invest in this. You can cheap out everywhere, but do not cheap out on this. That will directly affect your return on investment. Now then, of course, that creates DC. How you gonna sell it? You're gonna need a grid tie inverter. Now what is this? Nothing fancy, it just only works as long as there is a power coming into it. So it takes the power, 3-phase power, RYB or whatever it's classified in your country. It takes the 3 phases and then syncs the frequency exactly to like that. Is it 60 Hz or 50 Hz? The inverter is gonna take care of it. How the phase angles are there, inverter is gonna take care of it. So it basically allows you to sync. Basically this acts like a generator. So it takes the DC power, stores it in a capacitor bank. Sometimes you can buy inverters that don't even have transformers in them. Those are generally high efficiency ones, and that way you can get even higher efficiency and longer lifespan. So the grid tie inverter takes the power, uses that power itself as a catalog. Okay, like this is how much power I'm supposed to get, this is my frequency angle, and it syncs everything. The output from your solar farm goes to the grid because of grid tie inverter. So this is the basically bread and butter of your livelihood. And generally if you have a farm, generally people will urge you to have a string inverter. What is this string inverter? Basically it's a grid tie inverter where you can have multiple of them. Now sometimes they can raw work. Basically you have one, you connect another, third another, it does not matter. Sometimes they will have bit more advanced communication where they will have Ethernet or Wi-Fi connected to each other so they can talk and communicate. And obviously, let's say you have a farm, let's say it's 500 kilowatt or 50 megawatt. Do not have few inverters. Try to have basically appropriate number of inverters. Never have one inverter. Like let's say you built a farm, there is inverters that are 1 megawatt capable. Don't buy that. Buy 250 kilowatts. So in case of failure, you have at least 50% production. Do not buy something like 1 point of failure. Try to have at least some redundancy. That's why never ever have a large farm where you have one inverter and if it fails, your farm is stopped. Now you could do that. Let's say you found out some manufacturer, let's say ABB is giving you good discount on a big inverter because it's not selling much. Buy 2 of that to make sure that you can hot swap. Then almost all good inverters generally have MPPT. Basically what you have to understand about this is solar panels, when they are shaded, let's say a cloud rolls around, the panels that are shaded, they reduce dramatically in their amp output, and over time even their volt output. First the amp will be compromised, then the voltage will also go down, and that could trigger a fail-safe reaction where that whole solar panel is basically not producing any power because it goes below the cutoff voltage. MPPT allows the inverters to talk with it. It's like, okay, you are giving me less power, I'm going to draw less power from you. So that allows you to extract more usable power. So it's not magically adding more power to your system, it's just allowing more usable power to come because it can handle voltage drop. So let's say one array of your solar panel is shaded, is producing less power, MPPT can compensate for it. So many times you read these stuff in inverter, they will say like 5 independent system, 10 strings, 20 strings. These strings are basically where they can handle a fault, they can handle basically short circuit, they can handle a shaded area. So that is why we go for it. And efficiency matters. Do not cheap out on that. Let's say somebody says I'm giving you 93% efficiency and this is my cost, and somebody says 95% efficiency but cost is higher. Go for 95%. Efficiency matters. Now again, okay, let's say you made the electricity, you have the farm, you made the frame, you put the solar panel on it, you bought the inverter. What you do after that? You have to build your substation. Now again, you have to pay for this. Now be aware, if you are building very little amount of solar energy, let's say 1 megawatt or 2 megawatt, you may not need this. You simply may have 11 kVA basically high voltage and high tension line. You simply send it to substation, the nearest substation, and they may be able to absorb it into the grid and they will pay you the electricity amount. But in case of let's say you build 30 megawatt or 50 or 100 or 700 or 800, yes, then you need your own substation. You need proper substation for yourself. in those sort of scenario. And be mindful, your money will come from here. It will not affect matter like how much energy your inverter is making. It will matter how much you can sell from your substation, because government does not care. Like, let's say you lost 2% of energy from inverter to substation, that 2% is gone. It's not gonna come to your bank. So please, substation is also a crucial part. Now on small scale you don't have to worry too much about it, but in large scale, yeah, you have to spend money on this also. Especially if you are going, if you are even approaching 10 or 20 megawatt, get a substation, get a proper substation. And generally you have to worry about HV line or HT line, high voltage line or high tension line. So this is also a critical aspect, especially on big ones. Not a small one, you can bypass this by having only one step up transformer where you transform 240 volt to 11 kV. But in case of a serious plant where you have producing multi megawatt, you need substation. So okay, this is how you build the thing, how you're gonna maintain it. Now maintenance, first you have to understand, if it's a big farm, please have maintenance staff. You must have somebody there to like handle situations, like generally an engineer or something like that. All big farms have at least 1 or 2 people, and they're 24/7. So you have to have that. Now must clean regularly. This is a crucial aspect. If you are like waiting, like okay, I'm gonna clean like once a month, you're gonna lose a lot of efficiency simply by the fact that you waited for long. You're gonna lose, let's say 2% today. Now 1% dust added to your system, now you're losing 3%. You know, so don't wait for your solar panel to be clogged up by dust and then you're gonna clean it. That's stupid. So generally big large solar farms generally rely on this sort of situation. Now there are generally 2 versions, water version and water free version. This is a water free version. And this is why you want to have all your solar panel you know, as closely packed as possible. So this system is gonna ride on the rails, basically the frame, and simply gonna go up and down, up and down. And this is a microfiber, so do not worry, it's not gonna scratch your system. But again, let's say a bird is like shitting on this, you have to sometimes go and check it. So you need to spend time to, you know, make sure that it's clean. Some systems are very advanced, they only clean at night, so you don't have to like suffer any losses. And please keep stock spare parts, because let's say a bird directly suicide bombed on this and it damaged the panel, this whole string will be disabled. So for that, you to make sure that it comes back online, you must have spares. This is not a like a plug and forget situation. Yes, it's completely like a human free compared to other systems like a hydroelectric power dam or coal fire power plant, but it is not 100% human free. Like you still have to have some people. Mostly you will never need them, but you still have to have them just to go around, just to check situation, just to make sure that so if one string falls apart. Nowadays the inverters are so advanced that they will tell you string number 12 is damaged. So if you have named your system correctly, you will find, okay, this string, that means that solar farm or that solar array. So maintenance is also a crucial deal. You're not going to spend a lot of money into this, but you must have somebody there or have someone on a call that it will come on next day, because if you lose one whole day, you lost the productivity of that whole day. Now what about your investment? Like how long does it take? Again, directly depends on your state, how they're gonna buy it. I cannot tell you that because it's different everywhere. It does not matter whether you will get taxed or not, because everywhere it's different. I can't give you a one number, okay, this is the number, go with it. Everybody is different. You are building it for industrial sector, how big it is, because the money that you are gonna receive gonna change, and it's gonna change by every election. So your return on investment is generally approximately 10 to 15 years. Now you think that's not good enough. Yes, I told you in my very popular video on this channel about solar farm, I told you coal is here. Like coal still makes you profit, but solar has come to a point where it's starting to make profit. It's not there yet where, you know, you made something this complicated, this expensive, and you're gonna print money to instantly. Yes, over time you will. Over time, let's say 5 or 10 years, you will start to you know, go into positive. Your revenue will turn into your profit, but it does take time. Do not think this sort of investment is, oh, I have a free land, I'm just going to make a solar farm. It takes time, it takes effort, and not to mention, depending on your state, it may not be profitable. Please ask your local government. Please contact whatever local solar farm seller you have. They will tell you exact detail. Do not search on internet. Go somewhere like who sells you that thing and just ask them what is the unit. Because in Rajasthan, let's say you can sell electricity for 2.5, basically 2 rupees to 8 rupees. Somewhere you can sell upwards of 10 rupees. If you sell at 10 rupees, that's a lot of money. So please, do not just jump into, oh, solar farm, I can make it. It's expensive. It takes a very long time. It requires maintenance. It's not like, you know, a very magical scenario where you just, oh, I did something and now I'm happy forever. It does not work like that. So at this point in time, in 2019, if you want to build a solar farm, it's a good thing. but you have to be very thorough with return on investment. It's not guaranteed and it takes a very long amount of time. Minimum is like 5 to 7 years. So this was my presentation on solar farms cost. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it. You can dislike it. I would urge you to leave a comment because I reply to all of them. And please press the ad shown in this video. That will directly help me. Subscribe, press the bell icon if you're free. And as always, thanks for watching.